Okay, welcome back. Let's try a couple of more along these lines. This time it looks a little bit different. We've got x plus 1 minus the quantity 4 over x minus 2, and x minus 4 minus the fraction 24 over x minus 2. Now, if you don't recognize it, of course, these are fractions, although they're not really written as fractions. But we could think of this as being x plus 1 over 1 minus 4 over x minus 2 in the numerator. And we have x minus 4 quantity over 1 minus 24 over the quantity x minus 2 in the denominator. And we see that our least common denominator here would be 1 times the quantity x minus 2. And we'll just say, well, it's x minus 2 then. What's going to happen if we multiply that through? So that's what we're going to do here. In the numerator, I'm going to multiply through by the quantity x minus 2. Because doing so in this second fraction eliminates that denominator. And I'll do the same thing down here. I'm going to multiply the quantity x minus 2 into the numerator denominator. Again, remember, this is the equivalent of just multiplying through by 1. If it helps you to see it, you can put that over 1 so that it is a little bit more apparent what's going on right here when we distribute. Well, when we distribute, we're going to get x plus 1, the quantity, times x minus 2 for our first term, minus 4 in the numerator, where in the denominator I'm going to get x minus 4 times x minus 2 for our first term, since nothing cancels out with the 1 in the denominator, minus 24 over x minus 2 times x minus 2 over 1 is just 24. Well, this is actually a little bit simpler to handle, right? Because what's going to happen here is we're going to have to multiply through in the numerator x squared plus 1x minus 2x, so that's x squared minus x minus 2 minus 4 in the numerator. And in the denominator, x squared, x minus 4 times x minus 2 becomes x squared. Minus 2x minus 4x, that's minus 6x. Minus 4, minus 2, that becomes plus 8. Minus 24. So one more simplification reveals that we now have x squared minus x minus 6 in the numerator, and we have x squared minus 6x, and 8 minus 24, that's minus 16 in the denominator. So we want to see if there's any factorization that can help us simplify this out, and we should certainly look. X squared minus x minus 6, I happen to know, is going to be a trinomial that factors as x minus 3 times x plus 2. Now you can go through and work that out yourself. In our denominator, all right, well, it looks like we've got x and x here. We need two factors of negative 16 whose sum is negative 6. Yes, that's right, negative 8 plus 2. And it looks like the x plus 2 goes this time. And so our expression x minus 3 over x minus 8 is what's left over. And again, I'm going to say this is true as long as x is not equal to negative 2, nor, as we can see right here, x should equal positive 2. All right, one more. You're looking at yourself and saying, oh no, this is horrible. Well, it can be if we do go about it the wrong way, but let's look at our two fractions right here. We've got y plus 2 and y minus 2 in each of the respective denominators, and so that is our least common denominator, and we can actually just multiply directly through by that, oops, not x plus 2, it's y. So let's go with the correct variable here. Y minus 2 times y plus 2 as that least common denominator. So that's what we're going to multiply everything by right here. So let's try it. We're going to take y plus 2 times y minus 2 times the quantity y over y plus 2 minus y over y minus 2. And remember, this is over 1. So I'm going to do the same thing in my denominator, y plus 2 and y minus 2, my least common denominator, times the quantity in the denominator, which is y over y plus 2, plus y over y minus 2. All right, and here's what's going to happen. This quantity, these two binomials, get distributed individually to each of these terms. So you imagine y plus 2 times y minus 2 over 1 times y over y plus 2. Well, in that first term, the y plus 2's cancel, leaving us with y minus 2. Subtract from that y over y minus 2 times y plus 2, y minus 2 over 1. In that case, the y minus 2's cancel, leaving us with y plus 2. If it helps to see it, you can distribute that y plus 2 times y minus 2 to both terms individually so that it becomes a little bit more apparent what does and what does not cancel. Right? Same thing in the denominator. Y plus 2 times y minus 2 gets multiplied by both terms in the numerator and denominator equally. So canceling with our common factors here, y plus 2 cancels. Ooh, I forgot to multiply my y's, didn't I? Y here and y here. So I'm going to have to do the same thing down here. Y times y minus 2. This time will be added to y times the y minus 2's cancel, y plus 2. What does that mean for me? Well, in this case, if I distribute y squared minus 2y minus y squared minus 2y in the numerator would be divided by y squared minus 2y plus y squared plus 2y, and while there's many tempting things that it looks like I can cancel, I need to simplify by getting my like terms. Y squared minus y squared cancels that out, leaving us with minus 4y in the numerator. Y squared minus 2y plus y squared plus 2y gives me 2y squared in the denominator. And now that we look at the common factors, we're going to end up with negative 2 divided by y in completely simplified format. That's it. That is my simplified expression. More to come.